Welcome organic students, and nice to have you back again. Today we're going to talk about, I forgot. Let's see, where did we leave off on Wednesday? Wednesday we finished up with ketals and acetals, and we looked at them as protective groups. So let's talk about amines. Amines as protective groups was the one thing I wanted to discuss with you, and we'll start there. Okay, so right now we have two protective groups that we know of for alcohols. We have enosyl ethers. And we know we can cleave those with tetrabutyl ammonium fluoride or H3O plus to get back our alcohol. So if we wanted to functionalize something that also an alcohol reacts with, we can protect it and then deprotect it, and we'd be good to go. Hold on a minute, Krause is giving me fits, and I'm fixing to take him to the shelter. So give me 2 seconds. He has decided to tear up everything he owns, including his brand new harness, because I wouldn't let him tear up the markers. Okay, so we have that for enosyl ethers, and then we found out that we could take carbonyls and react them with alcohols. Doesn't matter what the alcohol is. Yesterday we used ethylene glycol, which had two alcohols within one molecule or two hydroxyl groups. We could just use two monohydroxyl alcohols and get a ketal or acetal depending on R. If R is H, we get an acetal. If R is an R group, we get a ketal. So we want to add a little bit of H plus to functionalize this. And then we found out ultimately, get out of that, ultimately that you can reduce that off using, take that back, excuse me, don't want to reduce it, we want to take it back to the ketone or the aldehyde, and we can just use H plus to do that. And of course we have our alcohols left over here. Alright, now for the amine, we've already learned how to do an amine, and amines we protect as acetyl groups. So we can have an amine, and we use acid halide, or we know we can use an anhydride to do this. Let me put a prime here so you know that my R group is clearly different. And so we can use an anhydride as well. And we can protect an amine this way. Now, these acetyl groups for amines come off very easy under acidic or basic hydrolysis. So we'll just put H plus or OH minus, acidic or basic hydrolysis. Okay? Now, what's another way we can react a carbonyl and get a group that can then be reconverted to a carbonyl? So ultimately another protecting group for ketones and aldehydes would be what's called a dithiene. So remember these three, and we're going to give you one more for the ketone and aldehyde, called the dithiene. I hope you can see this blue color good. Alright, so we'll take, let me do this. Let me use a dinger because I loved, when I was a student, I had a professor named Dr. J. David Talbert who was quite a guy, and I miss him to this day. And he used dingers instead of R groups. So we're going to use the dinger for David, and it just means the remainder of the molecule, which I am not showing. Okay? So we can react this with a thiol. We'll use methane thiol, NH+. Of course, we know this has 2 lone pairs. And if we use 2 of these, we're going to get what's called a dithiane. And to get that back, we're going to use mercury 2+ and a little water. And that will get us back to the ketone. So you can see we have another protective group that's very good for ketones. Mechanism, very similar to the mechanism for ketals and acetals. I would ask you as a homework assignment to go through and do this mechanism, and if you need me to work through it, I will for you. It works the same way. Just consider this an alcohol. Instead of an oxygen, you have an S, and try it and see how well you do. Follow the plan that we did on, I guess it was yesterday, when we did the ketal. Instead of an alcohol, you're using a thiol functional group. Okay, so this is another protective group for carbonyls, aldehydes, and ketones. Beauty of it is it's a little hardier than the acetal or ketal, which means it hangs around under various conditions better than H3O+, so it's a hardier protective group. If you're going to be doing some other reactions and you need to preserve your ketone for later, and those other reactions require harsh conditions, this may be the way you want to go instead of a ketone, or instead of a ketal or an acetal. So that's all I'm going to do today, because unfortunately my dog has decided to tear up everything in this room. And again, let me say I love you. I appreciate more than you'll ever know my students who mean the world to me. And be safe, maintain your social distancing, and never get a dachshund. Thank you.